Today we will discuss how to calculate area under a curve of a function which is non-negative. Okay. So suppose y is a function of x and x belongs to this closed interval AB. Okay. So now suppose we have a function like this, and this is A and this is B, suppose. Okay. Now, suppose we want to find out this entire area, okay, which is between A and B. So basically, what we really want to find out is this area. Okay. And this area is A. Now, let us try to have an illustration. So what will happen if I bound it till x? Okay. So let us define AX to be area under y equals to fx on closed and bounded interval a comma x. Okay. So you note that AX is an increasing function. Why? Because as x increases, now suppose my x increases to this x plus delta x, and where delta x is the change in x. So now this area has increased from A to x plus delta x. So area increases as x increases. Okay. So it is an increasing function. Okay. So AX is the area under y equals to fx on the closed and bounded interval a comma x. Okay. So now let us see what is the change in area. Okay. So change in area is what? Change in area is area on a comma x plus delta x minus area on a comma x. So area on this interval from a to x plus delta x is ax plus delta x. That is by the definition ax. And this is nothing but a of x. Okay. So basically, what is this difference? If we talk about this, so this difference is actually this pink area. Okay. So now, suppose now consider this product f of x plus delta x. So what is f of x plus delta x? So this is f of x plus delta x. Okay. And this is f of x. Okay. So suppose you consider a rectangle whose height is f of x plus delta x and whose width is delta x. Okay. So what area are we going to get? We are going to get this upper rectangle. So we are going to get this upper rectangle. Okay. And now suppose you consider a rectangle whose height is fx and whose width is delta x. So its area is length into breadth. So fx into delta x. So in that case, the rectangle is going to have this area. Okay. So what are we getting from this diagram? We are getting this information that this change in area, a x plus delta x minus ax, is greater than or equal to the area of the lower rectangle. So which is fx delta x. And this is less than or equal to the area of the upper rectangle, which is f of x plus delta x times delta x. Okay. So what we do, we divide this inequality by delta x. So we will get fx less than or equal to ax plus delta x minus ax divided by delta x less than or equal to f of x plus delta x. Okay. So now what we do, we take limit as delta x goes to 0. So limit as delta x goes to 0, fx is less than or equal to limit as delta x goes to 0, ax plus delta x minus ax divided by delta x less than or equal to limit as delta x goes to 0, f of x plus delta x. Okay. So now note one thing. This particular limit on the left hand side is nothing but f of x because it is not depending on delta x. This particular limit is again f of x because delta x goes to 0. So this limit goes to f of x. So now there is a very famous theorem on limits which says that if, hx less than equal to gx less than equal to kx are three functions such that limit, x tending to some number a, hx is equal to limit x tending to a, some limit, kx, if these two limits are equal, then the sandwich theorem says that limit x tending to a, gx is also equal to L. So basically what is happening, by this we are going to get this result that limit x delta x tending to 0, a x plus delta x minus a of x divided by delta of x. This is also equal to f of x because this limit and this limit are equal. Now, this is the definition of derivative of a. We can note that if fx is a function, then the derivative at a is nothing but limit x tending to a, f of a plus a, x tending to a. So this is going to be minus f of a divided by h. So h tending to 0. So when we calculate the derivative at a, this is going to be the derivative. So here h is replaced by delta of x. So this thing on the left hand side is nothing but the derivative of a. Okay. So the derivative of area function is fx. And what is fx? Fx is the curve under which we are trying to find out the area. Okay. So one observation is a dash x is equal to f of x. Now, suppose, suppose fx be a function, okay? Suppose fx be a function such that f dash of x is equal to fx. There can be more than one function because fx is equal to a dash x. We can have one more function where fx is equal to f dash x. Okay. So that means a dash x is equal to f dash x, which means that a dash x minus f dash x equals to 0, which means that derivative of ax minus fx is equal to 0. Now, when is the derivative of a function 0? Derivative of a function is 0 if and only if it is a constant function. So therefore, ax minus fx is equal to some constant c, okay, for all x. Now, this means this should happen for a also. Okay. Now, what is ax? If you remember what was ax, it was the area under y equals to fx on a comma x. So if you talk about a, it means area on the interval a comma a. That is going to be 0. We are starting and ending at the same point. So this implies that 0 minus fa is equal to c. So therefore, c is equal to minus of fa. Okay. So what we can write from here is that a of x is equal to f of x plus c, which implies that A of x is equal to f of x minus f of A. So, what is the moral of the story? Moral of the story is that if we want to find out area on A comma x under y is equal to fx, then that area is nothing but capital Fx minus capital Fa, where capital Fx dash is equal to f of x. Okay. Now, example. Suppose you want to find out area under y equals to x square on 0, 1. Okay. So you can note that y equals to x square is this parabola. Okay. So this is 0 and this is 1. So we actually want to find out this area. So now what is your f of x? F of x is x square. Okay. So if you do a little bit of observation, if you take capital Fx to be x cubed by 3 and you differentiate it, this is going to be 3x squared divided by 3. So you notice that capital F dash x is equal to x square, which is f of x. Okay. So that means my candidate for f of x is x cubed by 3. So now I want to find out this area. So I will write ax equals to fx minus f of 0 because a is 0 here. So a of x is what? This is x cubed by 3 minus f of 0, which is 0 cubed by 3, which is x cubed by 3. So this is the area function. Now we want to find out the area on the closed and bounded interval 0, 1. So that means my x is 1. So a of 1 would be x cubed by 3 and now you put x equals to 1. So 1 by 3 square units. So this is how we find out area under a curve where the curve is non-negative and the curve is bounded by the x-axis between two endpoints. And this particular function fx is called anti-derivative of fx. Okay.